Welcome. We want to give you a very warm welcome. Today we are presenting and introducing for first time our new series of Tech Tips webinars. We are preparing from the marketing team. I'm working together with my colleague Thomas Keplinger. My name is Adrián Soto Espinosa, and today's webinar will be focused on two of our products, the Huawei Smart Power Sensor and the Huawei Smart Dongle. Both components could be integrated in a smart PV scenario. And a smart PV scenario means that will be communicated and also will be possible to share important data information. That's only the introduction. I will go into details for it in the presentation. First of all, I want to tell you that we are happy to share this information. For further questions, please use the Q&A function. My colleague Thomas Keplinger is here and he will provide you with the right answer. At the end of this webinar, we will collect and we will choose the most interesting and attractive questions for the public. And let's start with our webinar. Enjoy. Starting with our agenda, our webinar is split in two sections. The first one will be dedicated to learn more about everything that has to do with the smart power sensors. We will start with the main functions to learn how to work with it and to reveal the main purpose of installing a smart power sensor inside our PV system. We will share product news, which is referred to the updates and upgrades from both of the devices. We will also show you the product compatibility to be familiar with the list. After that, we will continue with the features and highlights from the different types of smart power sensors. We will also show you where to find the technical details and what is the most important characteristics from each of the devices. Also, at the end, from both of the product presentation, we will include an application scenario. So now that we are ready and that we're familiar with our agenda, I will start explaining using this slide. This slide shows you a residential smart PV solution which integrates two new technologies in every photovoltaic system, which is referred as the energy storage system and the smart charger. So we know that our smart PV fusion solar product portfolio includes the Luna 2000 energy storage system, and the recent product or the newest product in our product portfolio is the EV charger for fast AC charging. Both technologies are integrated to provide a better experience of energy flow. Nowadays, there is a trend to increase our self-consumption, and for that, we will use the communication device and the smart management of the whole system. For that, we will use the smart PV management system. In other words, without the integration of a smart power sensor and without the integration of a smart dongle, it is not possible to achieve the full experience that Huawei technologies are providing to our customers. So we recommend to every installer to use them. And for further details related with the commissioning, the integration, and the whole visualization inside our Fusion Solar management system, we will get into details in the next slides. Continuing with the main functions of our smart power sensors, the smart power sensors can perform three different types of functions. The main ones, the measurement of electrical parameters. For that, we have learned in the past that our smart power sensor works together with what we know the AC current transformer, shortened the CTs. And using both devices, we can accurately measure electrical parameters such as power, voltage, current, the frequency, and power factor, which are very useful for the installer to know the status in the management system. The smart power sensor can also perform a bidirectional metering function. That means it can read the active flow from both sides, what we are consuming from the grid to supply our loads, and also in case that our PV production surpasses our loads, we will be redirecting or fitting in this PV surplus to the power grid, and this measurement is also possible using the smart power sensor. The communication. This is an important topic for the compatibility with external devices and third-party management systems. Our smart power sensor enables the communication protocol Modbus RTU using the interface RS485. So now coming to the product notification change coming from Huawei Power Technologies is that in our two scenarios, one phase and three phase, we have now a new name convention. So starting with our Smart PS 100 amperes S0, this smart power sensor is designed for one phase scenarios. How do we know that is for one phase scenarios? Well, if you look to the naming convention, we will start with the shortened version of smart power sensor, smart PS, continuing with the current measurement range from the CT, the 100 amperes, continuing with the termination S0 for single phase. This type of single phase smart power sensor includes by standard configuration, one CT with the referred technical characteristics with a current measurement of 100 amperes. Jumping to the three-phase PV systems installations, we offer the Smart PS 250A with termination T0. So recapturing what we already mentioned about the naming convention, now we can include, right, the three CTs with a current measurement of 250 amperes. So here in this type of three phases smart power sensor, the CTs are already included in your order. A special case for the smart power sensor is the Smart PS 80 amperes integrated T0, right? This type of smart power sensor is also known as direct measurement or optional CTs. That means that it can withstand a current measurement up to 80 amperes. And in case that we are working in an installation with a current measurement higher than 80 amperes, we will have to purchase the CT by ourselves. Here, a tip that we can provide to our customers or directly to the installers is that this type of CT should be closer to the expected AC current flow. So as we know from the past, we have provided only one smart power sensor manufacturer, or Huawei had only received a smart power sensor from Qing Electric. Now we can offer an alternative model, and that depends on what we have available. So for the sake of simplicity, once you place an order, you will use this identical code. Please use this slide referred to each of the single phase and three phase smart power sensors. Also, Official is that the integration of this information will be provided on our website, including the certificates, data sheets, and every important and relevant information related to this topic. Now, coming to the product compatibility. The smart power sensors are designed as a smart device to provide this communication and measurement for residential system applications. You will think, why do I need this type of smart power sensors? Well, because they can provide you with an intelligent measurement. I want to highlight using this slide that if you look to the connection here in this simple line diagram, we have positioned the smart power sensor always at the grid connection point. And with this, we would have the bidirectional flow or the correct bidirectional measurement from the energy coming from the grid and the PV surplus coming from our own photovoltaic system. The compatibility is referred, the single phase covers the inverters from power classes 2 till 6 KTL, the L1 series. For the three-phase inverters, we offer the power sensors, right? 250 and 80 IA, T0, and the power classes that can work with this type of smart power sensors are power classes 3 till 10 KTL M1 series. So here I'm presenting the features and highlights from our single-phase smart power sensor. On your right side, you can see both images, which is, you can use it as a reference to learn the appearance of how the smart power sensor looks. As you have noticed, the appearance doesn't change at all, or it slightly differs from one another, but their technical characteristics remain the same. If you want to direct your attention to the technical details, we do recommend to check our website and you will find the relevant information provided. Here, I summarize some of the features and highlights that will be very similar from the single-phase and three-phase scenarios, but I will highlight some of the difference and make note on the importance of each of them. Starting with the bidirectional power meter, as we know, the single-phase installations, now the naming convention is referred to the S0. The communication to the inverter is via interface RS485, the Modbus RTU. The high accuracy measurement within an error less than 1%. The automatic detection in Fusion Solar app during commissioning is also an advantage that these smart power sensors provide. They also provide a real-time communication. That means the update of the data goes in a time lapse less than a fraction of a second. The specific information, you can find it in the datasheet. The main component for the smart energy management, including the Luna 2000 energy storage system control, is the smart power sensor. And for a dynamic power limitation, also known as the export limitation, you will need a smart power sensor. For this type of single-phase smart power sensor, one CT with a current measurement of 100 amperes is included. The next one, the Smart PS 250 amperes T0, features the same technical characteristics. On your right side, you can see the appearance of both smart power sensors, right? From Kind Electric and Yada, our alternative manufacturer. The difference here is that from the one phase is that for this type of installations, we will have to use the included CTs with a current measurement of 250 amperes. The last one, also for three-phase applications, is the 80 amperes integrated T0. On your right side, you can see the appearance, which slightly differs from one another, but their technical characteristics remain the same. Important to highlight is that this type of smart power sensor can be connected directed to the system, providing a direct measurement. That's why we can recognize it also as direct measurement or optional CTs. The next slides will provide you with some of the most relevant information related technical specifications. Different from the past, we can also check the baud rate for fast communication. What we know as a unit of fast communication, the bits per second has changed or can be also configured. The default value is the 9,600. We can also check the operating temperature if this type of, covering a wide range of temperature to be installed, either indoors or outdoors, but commonly is this type of electrical components for protections are included in the same distribution box. The installation mode is DIN 35 rail mounted. Here, the technical specifications from the previous models remain the same. So if you have further doubts, I would recommend you that please use our datasheet to get familiar with some of the current measurement range, the Volta measurement range. Of course, you don't have to learn it by heart, but it's always good to know where to find it and to have it at hand. Coming to our application scenario, using this type of application scenarios, we can learn more about the features and to finally understand the purpose of integrating this type of components in our photovoltaic system. The first scenario is referred to the Luna 2000 energy control, right? The smart power sensor, which is the core component for a household energy management, it is used to realize power adjustments regarding the charge and discharge control towards the Luna 2000 energy storage system using the communication protocol Modbus RTU. The Luna 2000 can respond to commands from the inverter in real-time query. We have to mention that in order to provide this type of control and further to provide the commands to the Luna 2000, the power adjustment can be configured directly to our Fusion Solar management system. Here are the steps. So this is a small introduction of the working modes of the Luna 2000, which refers to the charging from the grid, the control modes, fully fed to the grid, time of use, maximum self-consumption, and so on. We can also use this slide as a reference to understand how the system will be communicated. Well, we have to remember that our smart power sensor will be located at the grid connection point. We will also include, beside this smart power sensor, in every installation is normalized to have a second power meter, but this one comes from the energy supplier, right? But for our own use and for our management and our communication to a third-party management system or our Fusion Solar management system, we do have to install the smart power sensor. It communicates via Modbus RTU protocol directly to the inverter, and the inverter is communicating again to the Luna 2000. So this is how it looks. The export limitation, it is a subsequent application scenario from this type of photovoltaic systems, including the energy management or power adjustments. We can recall some countries, for example, Germany, that the grid supplier, or sorry, the grid operator makes a requirement of an export limitation up to 70% of the installed capacity in kilowatt peak. This type of power adjustments, or in our smart fusion solar management system, we can refer as export limitation, and we can control as a matter of percentage of the total installed capacity. And to do that, of course, we will have to do the measurement directly at the grid connection point using the smart power sensor. Some interesting application, which is new, as house owners are opting to use the surplus energy to charge their own electric vehicles in order to increase their self-consumption rate, is the PV charger solution. Here, interesting is that this type of application includes both of our products here presented. The smart power sensor to establish a communication between the smart power sensor and the inverter, and the smart dongle, which provides a communication between the inverter, the router, and the EV charging station. So in this type of a scenario, the charger compares the grid connection point information reported by the meter with the total current setting of the main circuit breaker to quickly adjust the charging power and prevent the main circuit breaker from tripping. When PV power preferred is enabled and the meter detects that the PV system has surplus, the charger uses the surplus power for vehicle charging and implement a dynamic charging power based on the PV system. So now, at the bottom of this slide, we can check how the communication and the networking is performed. First, using the smart power sensors to the inverter, and then the smart dongle to the router, and then a fast Ethernet cable to the EV charger. So in a simple description of this type of application scenario, we integrate this communication networking that in real time we can do a load balancing. For optimal operation and to keep the system protected, there's a safe threshold that we cannot surpass. So here in this, on the right side, at the lower part of our slide, we can see where does the safe threshold is located. We can also observe the sum of our total consumption. So imagine that we are producing energy or PV energy, and it is used to charge our electric vehicle. At the time that we at our house are using home appliances, and there's a rapid load which is consuming, the charging power will reduce to trying to not reach the safe threshold limit. And in this way, we will also control the charging from 3-phase to 1-phase. And this is also something that we will explain in further detail in our next webinar. So please keep tuned. We will provide you more detailed information on how to work with this type of applications, and also how to easily integrate this type of products. So hope that you have enjoyed this first tech tips webinar. We are expecting you to visit us again. Please get online, send us your questions and comments to improve also. And till next time. Thank you very much.